Hello Newtonians! In this video, we will learn about the required skills for a mechanical design engineer to achieve a great career. This video is quite long, so take your time to absorb all this. From what I learned in my professional life, after hours and hours of thinking about it, here's the list of the skills that would be the most important ones for you to succeed as a mechanical design engineer. Mechanical engineering knowledge. Industry knowledge. Technical skills. Communication skills. Analytical and problem-solving skills. Decision-making skills. Organization skills. Creativity. Most of the time, during my master's studies, I worked in the industry. I spent most of my living hours either working or studying. Immediately after I finished my studies, I opened my company. I moved to a different city, and everything went well for a while. But very soon, everything started to decline, and it escalated to the point that just 6 months after I opened my company, I had to close it. Ashamed and defeated, I had to look for a job in some other company because I had to eat something. The amount of the "I told you so" I got was overwhelmingly high. For some reason, others found my failure a perfect inspiration for constantly reminding me what happened. I was not able to figure out what went wrong. I was always a hardworking person, and I still failed. So, I did what every normal human being would do. I blamed everyone and everything. I could not stop pointing fingers around me, trying to prove that this was not my fault. At the early beginning of my new job, I said to myself that I would get to the bottom of this. I would find out who was responsible for my failure. I was 24 years old when I first heard about self-improvement. I stumbled upon one video from Valuetainment, The Life of an Entrepreneur, and I found about this guy named Patrick Bet-David. I started consuming his content and found the list of the books he would recommend, and the first book I read on this topic was Napoleon Hill, The Law of Success. So, after many books read, videos watched, and courses attended, I finally found someone to blame. Finally, I pointed my finger at the mirror. I started figuring out what I did wrong and what went wrong from my side. I spent countless hours thinking about what went well and what went wrong, and why. I learned about my strengths and weaknesses, self-motivation, grit, compound effect, visualization, planning, strategy, human emotions, and human nature in general. I read about neuro-linguistic programming and whatnot. I became obsessed with getting better. And, of course, I kept learning about mechanical engineering. I moved from Croatia to Germany without knowing the language and landed the job in 2 months. I started to work for Fortune 500 company before I turned 27 years old. I am not saying this to brag about it, but I want you to see that it is possible. If I could do it, you can do it too. Please keep in mind that if you are not ready to work extremely hard, go through an excruciating process and sacrifice a lot to get to a new level, there are no books or blog posts, videos, or courses in this world that will give you overnight success. Also, it will take you years to improve all of these skills. Therefore, depending on your current phase in life, make a plan based on your priorities and focus on improving them. The skills listed here are based on my opinion and experience. Mechanical engineering knowledge. The first one, of course, is knowledge of mechanical engineering. I am pretty sure you are now thinking something like, "No, Sherlock." While this one may seem that it is implied, there is a reason why I put this one as the first one. Your entrance to this position is probably a bachelor's or master's degree. I met many people who want to work on some high-level stuff without really understanding the basics of mechanical engineering. And I do not mean sit down and learn for exam understanding. I am talking about really understanding the governing principles behind mechanical engineering concepts. I am not implying that you should know all the concepts from the top of your head. You will, during your career, use some concepts more than the others. And those that you will use, you should learn and understand as much as possible. That will demand some work in your free time, but in the long run, the return on investment will be worth it. For example, you may or may not be familiar with the finite element method, FEM. The first lesson when I took this course was garbage in, garbage out. In order to properly obtain and understand the results of the finite element analysis, you should have a great understanding of mechanical engineering principles. You might not be a person that will conduct FEA in your company, but if you want to interpret the results, you still have to know the principles behind it. You do not want to be one of those people that open Autodesk Fusion 360 and take a CAD model, define some loads and constraints, generate a mesh and get the results. And then you tap yourself on the back, so proud that you managed to get the picture colored with as little red as possible. So basically, your knowledge of the topic comes from 3 places: your head, learning materials, and your network. You know something as long as you have one of these 3 things available. Tips on how to expand your mechanical engineering knowledge. My first advice for expanding your mechanical engineering knowledge is to invest time in finding the books, websites, and courses that could give you the necessary answers and knowledge. If it requires money, spend as much as you can possibly afford. There is no greater investment than investing in yourself. I spent a great amount of money on the proper learning materials, and it all paid off. The second piece of advice is to network with the people whose strengths are your weaknesses. Find out if there are any experts on the topics in question inside your company or your immediate circle of acquaintances. Furthermore, find out if there are any external consultants with whom your company is cooperating that are available to you. If any of these persons that you thought could help you cannot, there is a high probability that they could point you out in the direction of the person that could. So always ask a simple question: do you know someone that might be able to help me? Use a technique called product decomposition. Basically, take any product laying around your house and disassemble them. Create freehand sketches of different components and assemblies. Think about the materials that could have been used to manufacture it, feel the surface finish below your fingers, and investigate interesting features on the components. Disassembling and assembling different products are also beneficial for your hand coordination, and you will get used to using different tools. Ask yourself if there is an easier way to assemble this product. Would you make any design changes to make it easier? How many standardized parts were used, and how many were not probably used? I believe that product decomposition is a great exercise that will improve your skills significantly. If you are working in a company that has in-house production capabilities, spend a lot of time in production talking with the assembly workers. Gather their experiences about the different products they assemble. In the end, you will design products that they will have to later on assemble. Look into the legacy products in your company, preferably get them physically in front of you. Analyze them and look into the engineering drawings. Then, whatever you do not know, or you just find it interesting, go into the production, if possible, and try to assemble it yourself. I could create a list of what you should focus on to learn, but I will say only this: learn how to make a proper engineering drawing. Industry knowledge. When you start working on your new job, you will know little to nothing about the industry that you are working in. However, you will build this knowledge throughout the years you will work in this industry. What types of standards are required from your products to be compliant with? What kind of testing your products must undergo? What is the profile of the customers in this industry? What is the status of the industry and its future? In what direction companies' competitors are headed, and what is your company's position regarding them? What technologies impact the industry, and could they significantly shift your industry trends? How is the geopolitical situation influencing your industry and your suppliers? Some of these questions will be more important than the others, depending on the company you are working in. However, getting a deep understanding of the industry will position you on the path to mastery in your job. Knowing all these things for you as a mechanical design engineer will give you an idea of what your customer wants and may want in the future, giving you an early start on predicting and implementing new solutions before your competitors do. Furthermore, by understanding the challenges in your industry, you will be able to predict the problems that could occur and will give you a head start in addressing them. Tip on how to expand industry knowledge. The first step in acquiring industry knowledge is to pick the brain of the people that already spent many years working in that industry. Ask them about the industry, trends, and where they get their information. If they have some interesting newsletters, websites, etc., that they follow, you do not have to conduct the interrogation and pour all the questions immediately. Talk with the people in your company and build rapport through genuine interest in what they have to say. In addition to straightforward questions regarding the industry, you can also try to get their opinions. This will give you insight into how they are processing information about specific events in your industry. For example, the question could be, in our last meeting, you talked about the X, Y, Z trend. What do you think could it influence A, B, C? Technical skills. On your job, you will use different software and tools that will make you faster and more efficient. At least, that is their purpose. But there is a downside to it. If you do not take the time to learn how to properly use software and tools, they could make you slower and more prone to error. Therefore, technical skills are fundamental skills you need to learn. For example, writing on your keyboard with your 10 fingers without looking at it. If you do not know how to write without looking at the keyboard, your fingers cannot follow your brain, you are inefficient and slow. To learn to type with 10 fingers, you can find free websites that will help you elevate your typing skills to a new level. This goes for all the software you use: email, CAD software, simulations, ERP, Word, Excel, PowerPoint, cloud, search engines, etc. Investing time in developing your technical skills will give back great dividends. There are many different ways to get proficient in using different software. The first thing that I would recommend is, of course, YouTube and Google. You can find everything from the whole software course to solutions to specific problems. Write in the search bar the issue that you are trying to resolve. For example, how to knit surface in software ABC. If you are using new software, ask your manager to provide the resources for the training/course that will help you become proficient in using that software. These training/courses could come directly from different companies or websites like Udemy. Learn how to standardize your work in the software you use most. A well-predefined template is your good friend. Communication skills. I am not sure what is your first thoughts when someone mentions that someone is an engineer, but for a long time, I would imagine someone who is socially awkward. I am unsure if the reason is movies or TV shows, but that is just what I thought. Now, however, I definitely think differently. I met many engineers who are quite communicative and charismatic personas who actually know how to behave in front of other people. One of the things that you will be doing as a mechanical design engineer daily is communicating. You will communicate with your teammates, suppliers, customers, management, assembly workers, specialists, trainees, etc. There are usually 3 types of the communications that you will use. Verbal and nonverbal communication. Talking with people face-to-face in meetings, hallways, lunch, etc. Face-to-face verbal communication also transmits the nonverbal cues to other people you are talking to. Nonverbal communication is your body language, facial expression, tone of voice, eye contact, etc. Furthermore, you can communicate with others online. If your camera is not working, in addition to your verbal communication, the most important nonverbal communication will be your tone of voice, loudness, pitch, etc. If you are presenting something, in addition to verbal and nonverbal communication, you will also communicate in writing and pictures. In addition to going to a pub and talking with people, here are some additional resources that helped me increase my verbal and nonverbal communication skills. Course: The Complete Communication Skills Masterclass for Life by T.J. Walker on Udemy. How to Win Friends and Influence People by Dale Carnegie. Body Language: How to Read Others, Detect Deceit, and Convey the Right Message by James Borg. Written Communication. As a mechanical design engineer, you will communicate extensively with email. Based on the company, you could communicate internally through collaboration software like Microsoft Teams or any other software your company prefers. Therefore, you want to ensure that your writing is as clear and concise as possible. Furthermore, you should practice writing. Writing is an extremely powerful way of structuring your mind. Through writing, you can see how some of the topics in your head are unorganized and scattered all around. Regarding the writing, I cannot give you any special tips on how to improve your writing except sit down and write as much as possible. I can, however, give you a hint on your English grammar. If you are like me, and you are not a native English speaker, there is a tool called Grammarly. Grammarly is a writing assistant that will help you with grammar, spelling, and punctuation. I use Grammarly all the time. It is integrated with my MS Word, Outlook, and Google Chrome. I am using it for this article, for emails, reports, presentations, etc. The price I pay a month and the value I get as a non-native English speaker is immeasurable for me. Whenever I am not sure about my writing, I go to Grammarly. Engineering communication. You will have to prepare many different presentations like design reviews, reports, graphics, technical emails, etc. The special thing about engineering communication is that you will use pictorial communication in addition to verbal, nonverbal, and written communication, different exploded views, cross-sections, graphs, concept sketches, load diagrams, etc. What is even more challenging is that after you remove the verbal and nonverbal parts of the communication, the communicated message should stay the same for years to come. That basically means that in a few years, after you leave the company and someone needs your report, everything should be clear and understandable from it. This may sound hard, and you are right. The approach for preparing presentations, reports, etc., depends on the type of audience on the receiving end. It is not the same when you are preparing the presentation for the managers or other team members. For example, if the audience is more involved in the design process, they may be interested in the details, while the managers may not. The same thing goes for the meetings. What and when to discuss to have an efficient meeting and to convey a proper message is never easy to decide. The tool I am using the most that is making my engineering communication easier is a tool called Snagit. Snagit is a screen capture and recording software that allows me to take a screenshot of my desktop or region of a desktop and immediately edit it. I use this tool for most of the technical pictures created for my website and videos on YouTube. I can add lines, arrows, shapes, different effects, automatically numbered bubbles in different colors, and much more. One of the exciting features is a screen and audio recording possibilities. I can quickly create a video instruction and share it. Snagit will definitely make your life easier. I have not found any materials on this exact topic, so if you would like me to share my experience and knowledge, let me know in the comments below. Analytical and problem-solving skills. In simple words, analytical skills are the ability to analyze information and draw conclusions from it. Problem-solving skills are abilities to identify and understand a problem and solve it. In our line of work, we all use these skills, whether we know it or not. We are constantly analyzing the information that we receive, and we are drawing a conclusion from it. For example, if I change feature A, that will influence feature B. The outcome of our analysis is highly dependent on the information we gather. The more information we have about the specific subject, the better conclusion we can draw out. I will try to give you a generic example. Let us imagine that we have a product that sometimes fails and sometimes does not. The first thing we have to do is gather information about how many products failed from how many. This information will immediately give us an idea of how severe the problem we are facing is. 10% or 50% is a big difference. Also, in most cases, higher the percentage of error, the easier it is to figure out what is wrong, not necessarily easier to fix. The next step is to figure out under what conditions we have a failure. That means that we will, depending on our problem, start collecting information about the failure. You will talk with the person who reported the failure or read the report about it and what led to it. We could have two scenarios. The failure mode is known. If the failure is known, for example, I did A, and then failure happened, then we can move forward by replicating the steps that led to the failure to prove that was the case and that there were no other conditions contributing to this failure. Once we prove that was the reason for the failure, we can proceed with analyzing if this failure should or should not have happened. That means reviewing our user cases, calculation reports, intended environment, product specifications, etc. This will give us information on whether we should continue with our analysis. For example, our product is rated up to -10 degrees Celsius, but it was in an environment that was on -20 degrees Celsius, and failure occurred. The decision if we are going to upgrade our product or not to fit this use case is not a concern in this analysis. In case that failure occurred when it was not supposed to happen, we must proceed to gather more information on what could have led to this failure. Depending on the failure, you will measure the components, check the tolerances, and tolerance stack up, investigate the assembly process, look into the defined loads, and compare them with the loads that appeared during the failure. We will basically not leave one stone unturned until we truly understand the reason behind it. The result of our analysis should be a clear problem statement. For example, the failure on the 3D printer that resulted with the printing head colliding with the print bed was due to the distance sensor being mounted too high during the assembly process. The failure mode is unknown. If the failure is unknown, for example, it was laying on the desk, and out of nowhere, it failed, we first have to determine the reason for the failure. So we are going to start by analyzing the failure and its outcome and then assume different failure modes and proceed with experiments until we prove the reason for failure. Once we do that, the steps afterward are the same as in the previous scenario. Usually, with this approach, we will already have some information about what could possibly lead to the failure. Once we get our problem statement, we can proceed with solving the problem if needed. The first step is to define what exactly we want to achieve by solving this problem. Sometimes, it will not make sense to solve the complete problem but a fraction of it. This will require a decision to be made. Next chapter. Basically, we will decide either to solve the whole problem, part of it, or none of it. Yes, sometimes doing nothing at this point of time is also a solution to a problem. The next step is to generate possible solutions. In our previous example of a 3D printer's sensor being mounted too high during the assembly process, We can have multiple solutions like updating the assembly instructions, creating a fixture for mounting the sensor in the proper position, redesigning the sensor's holder, and updating the drawing. After we generate the solution, we must analyze it. Which solutions give us the highest value with the minimum resources spent? Maybe we could combine two solutions, one used as a short-term and the other as a long-term solution? What would it take us to implement it? Naturally, after this previous step, next step is to make a decision. Our final step is to plan and implement this solution based on our decision. For our previous example, the short-term solution is to update the assembly instructions, and the long-term solution is to redesign the sensor's holder so that it is impossible to mount the sensor too high. Analytical and problem-solving skills are highly valuable skills to have. We are using them all the time, and we should keep developing them. These skills could be a big differentiator between you and others. Here are some tips. Always keep your mind open to new ideas. No matter how stupid the idea you think it is, it might lead to other valuable ideas or insights. No matter how stupid you think that your failure mode is, consider it. No matter how stupid you think they are, the warning labels were put with the reason someone actually did what the warning label is saying not to do. I saw a warning label saying, "Do not put your credit card in the opening for the parking card," and I am pretty sure it was not there without a good and funny reason behind it. Always gather information on the products you are working on and similar products to yours, and have a designated place to store that information. You never know when a similar problem will occur to you, and you will want to have a head start on your information gathering process. Learn supporting techniques like problem analysis, root cause analysis, fishbone diagrams, the 5 whys technique, etc. Learn how to ask good questions. Learn how to use techniques for generating ideas, like brainstorming. Keep pushing even when you think you are not going anywhere. Sometimes, the correct insight will come when you are not expecting it. Properly document your process and experiments. My approach is like this: if I go for 2 weeks of PTO next week, will I be able to continue when I am back? If the answer is no, I know that I need to better document my progress. If you are using abbreviations, always write down the legend. It happened to me more than I would like to admit. I would look into my poorly written notes and wonder what GLUC and GRUC meant. When being asked your opinion about different problems or failure modes, you can give your opinion, initial gut reaction, but always make sure that you finish your thoughts with, "But in order to have the better answer, I would need to conduct proper analysis to draw out correct conclusions." Decision-making skills. Decision-making skills are the ability to select the optimal solution between one or more alternatives. These skills are also something that we use in our everyday life and work. We constantly weigh the different options to get to the optimal decision. Everything we do and achieve in our personal and professional life is based on our decisions. While the decisions in our life are often made based on our feelings, intuition, subjective opinions, and personal goals, mechanical design engineering decisions are made, at least they should be, based on the information we have. Usually, they are backed up with some kind of analysis. For example, our goal is to produce a cheap consumer product. Therefore, we could create a quantity/cost diagram of different manufacturing processes and decide based on that diagram. For decision-making, information plays a huge role. You should gather as much information as possible before making a decision. In mechanical design engineering, the decisions are rarely one-dimensional. Every decision that we make usually impacts more than just one thing. For example, we had some issues with the tolerances on our components. We analyzed the problem and have a few solutions we could implement. We decide to change tolerances and update our drawings. As a result of this decision, we have an additional cost related to changing our drawings, creating an ECR, and properly documenting the change. We are also impacting the component's price because now, with the tighter tolerances, our supplier must add additional setup costs, extra time for manufacturing, and use more expensive equipment for measuring the component. All these things I listed before should have been involved in the decision-making process. When we get to the point where we have solutions, we already know that our solutions will work. Now with our decision, we are determining what kind of impact our solution could have. The questions, of course, are: is our decision cost-effective, and does it bring the value we want it to bring? Answer to these questions should be answered before we make a decision. Here are some tips. Gather as much information as you can before making a decision. This information could include scientific analysis, cost analysis between solutions, Value analysis between solutions. For example, some solutions may be less expensive, but they are bringing less value to our customers. Risk assessment. Inputs from your coworkers and other experts. Always have a complete overview of why you made a certain decision. You do not want to say to your boss that you do not remember why you made a decision, but you know it was right. If you have a big decision to make, and you have time to make it, sleep on it. Sometimes you will have to get your decision approved. When you do, always try to get a written confirmation. When making a big decision, permanently archive all the details. This should go without saying, but always make ethical decisions. Organizational skills. One of the biggest compliments I received as a mechanical design engineer was when I was told I was really organized. I would say that this is one of the most prominent characteristics of a great engineer in general. Usually, we are operating in the domain of chaos, and being able to introduce some order in that chaos could be a difference between the success or failure of the product. In general, you have different project managers making sure that everything is going according to the plan and the budget, and you have product managers making sure that the right things are developed based on the customer requirements. It does not matter how many managers you have and how many plans they make, you will have to keep your side of the project on schedule. As a mechanical design engineer, you will work with many people with different levels of responsibilities. For example, you will work with managers, marketing professionals, sales professionals, and other engineers from quality, testing, or production. You will have different teammates developing different product segments. Furthermore, you will have different regulatory bodies which standards, certification, or compliance requirements your design must satisfy. Then you, of course, have your own responsibilities from designing, prototyping, testing, simulations, calculation, etc. Then you will have to prepare reports, attend meetings, and solve problems. Furthermore, you will have to eventually create engineering drawings adjusted for different manufacturing technologies. You will have to talk with your suppliers and get quotes. Then you will have to set up BOM and create and maintain the data inside of your ERP system, etc. As you can see, the input and output information you will get are enormous. You have to be able to organize and prioritize all of your project work and tasks. Here are some tips on how you can get better organized. Learn how to use your email software. Organize your email, create project folders and subfolder, highlight specific keywords, categories of your emails, etc. For each specific project, issue, or topic, create an approval folder and keep emails with approvals there. For the things that have a big impact on the product or your work, ask for an email confirmation. If you get a request to do something, always get your manager's approval for your time. Keep 2 separate task lists. One with all the tasks you should do, and one with the priority tasks. The priority tasks always keep visible. Always write down all of your tasks, do not keep them in your head. Learn how your company is organized. For example, who is responsible for what, and who is a go-to person for what. Learn the documentation release process in your company. Always take a conservative approach when giving a time estimate for your work. There are always things that could go wrong. So under-promise, over-deliver. If your task is connected to other people, estimate your work with the if statement. If person A finish this by tomorrow, I will be able to finish my work by the end of the week. Standardize your report and presentation templates. Always keep the notes during the meeting, so-called meeting minutes. Keep your design journal up to date. Archive all the relevant information in your knowledge base. Creativity. Creativity is the ability to recognize ideas to solve problems in a way that has not existed before. This could also be applied to communicating with others, approaching situations, or entertainment. Why is it important for the mechanical design engineer to be creative? Every day you will solve different problems, and it will require a lot of creative energy to get a satisfactory solution. You will have to figure out a new technical solution, new ways to test your products, more efficient ways to communicate your design intent and solve all the other challenges that come your way. Sometimes you will have to juggle between different tasks that are technical in nature and then switch to creative work and go back to technical tasks. It takes a lot of energy and practice to switch between the tasks and summon your creativity when you must. In our line of work, you cannot wait days to get the inspiration to do creative things. Here are some tips on how to get your creative juice going. Create a trigger. I have been working in this field for quite some time. I have been working on the same tasks for days and weeks, and I have been working on several tasks a day, switching between the technical and creative work. What I found that works the best for me is to have a trigger that will get me in the mindset of generating ideas. My trigger is when I take a pen and paper and start drawing. I have been doing this for so long that my brain automatically switches to the exploration mode. Use a 3D model to visualize different options. Sometimes, when the assembly I am working on is too complex and has too many constraints, I use a 3D model to completely understand all of the limitations and space I have for connecting my component to existing assembly. Having constraints laid out in front of you will give you a roadmap to your solution. Again, I would use a pen and a paper, and I would separately solve each constraint on a paper, generating all my options and ideas. Then I would combine different constraint solutions until I get one solution covering all the constraints. Practice exploring new ideas without technical analysis. The most challenging thing during the idea generation process is to stop analyzing ideas that are coming out. What I mean by that is that when you draw potential solutions, your brain will automatically start analyzing the solution to see if it fits all of your criteria. In the ideation process, that is not a good thing. Instead, what we want to achieve is to have a free flow of ideas, because even the ones that are not technically feasible could lead to a different, better solution. Learn things outside of your industry solutions. Knowing how different devices and products are solving various problems for other people outside your industry could inspire you on how to solve problems in your industry. For example, the haptic feedback from buttons on your remote control could give you an idea or a reference point for the haptic feeling on the product you are designing. Write your ideas down. During the ideation process, you could have a lot of different solutions that will not fit your current problem. But that does not mean it will not work for other problems you could sometimes have down the road. Write down your ideas in your knowledge base or where you feel comfortable storing them. Practice, practice, practice. Like with everything in life, the more you practice, the better you get. So spend time daily generating new ideas of any sort. Think about how different products could work and how they are made. Give your imagination a playground to grow and expand. Think big and think freely. Create imaginary what-if scenarios and let your imagination go wild. With practice, you will get better for sure. To become an excellent mechanical design engineer, many skills need to be perfected. But I would say that is required for excellence in any profession. Developing these skills will take time, sacrifice, planning, deliberate practice, and hard work. But if you are ready to pay the price to achieve excellence, you will reap the fruits of your labor. Being a mechanical design engineer can be gratifying career-wise and money-wise. As you get better and gain experience, you will feel more confident in yourself and your abilities. So, keep working, keep grinding, be smart about it, and you will achieve great things. Do you have any questions for us? Let us know in the comments below. Do you like our videos? Then, give us a thumb up, comment, and share it with your friends, colleagues, and on your social media channels. And if you want to become a part of the Newtonians, make sure to subscribe to our channel.